Earth to Mars, humanity's path to a new world. Mars, the fourth planet from the Sun, is a rocky world known for its reddish hue. It is our closest planetary neighbor with potential for harboring life. Here's a glimpse into the red planet. Surface: Mars is a cold, desert world with a thin atmosphere. Its surface is covered in dust and rocks, with features like volcanoes, canyons, and polar ice caps. Size and distance: Mars is roughly half the size of Earth, with a diameter of about 6,779 kilometers, 4,217 miles. The average distance between Mars and Earth is about 142 million miles, 228 million kilometers. Atmosphere: the Martian atmosphere is very thin, consisting mainly of carbon dioxide, argon, and nitrogen. This thin atmosphere provides little protection from solar radiation, making the surface a harsh environment. Moons: Mars has two small moons, Phobos and Deimos, which are thought to be captured asteroids. Potential for life: with evidence of past water and ongoing research into its subsurface environment, Mars is a prime target in the search for extraterrestrial life. Missions like the Perseverance rover is currently searching for signs of ancient microbial life. The exploration of Mars is an ongoing endeavor, with rovers, orbiters, and lander missions providing valuable data about the planet's geology, climate, and potential for future human habitation. Earth versus Mars: a tale of two planets. Our solar system harbors two very distinct rocky planets: Earth, the vibrant blue oasis teeming with life, and Mars, the rusty red neighbor with a mysterious past. While they share some similarities, the differences between these two worlds are vast. Let's delve into a side-by-side comparison. Size and atmosphere: a dramatic disparity. Earth, our home planet, boasts a substantial diameter of 12,742 kilometers. A thick atmosphere, composed primarily of nitrogen, 78%, and oxygen, 21%, surrounds it, providing vital protection from harmful solar radiation and enabling liquid water to exist on the surface. Mars, significantly smaller than Earth, Mars has a diameter of only 6,779 kilometers. Its atmosphere is thin and cold, dominated by carbon dioxide, 96%. This thin atmosphere offers minimal protection from radiation and contributes to the planet's frigid temperatures. Temperature and climate: a world of difference. Earth enjoys a comfortable average temperature of 15 degrees Celsius, thanks to the greenhouse effect from its atmosphere. This allows liquid water to exist on the surface, a key ingredient for life as we know it. The planet experiences diverse climates, ranging from scorching deserts to frigid polar regions. Mars is a frigid desert world with an average temperature of -63 degrees Celsius. The thin atmosphere offers little insulation, causing extreme temperature variations between day and night. Liquid water cannot exist on the surface due to the low temperatures and pressure. Moons and water: clues to past and potential. Earth has a single, large moon, a celestial companion that plays a role in stabilizing our planet's axis and influencing tides. Liquid water covers a significant portion of Earth's surface, around 71%, creating vast oceans and shaping the planet's climate. Mars has two small moons, Phobos and Deimos, believed to be captured asteroids. While Mars has no liquid water on its surface today, there is evidence of past flowing water and possible subsurface ice deposits. This hints at a potentially wetter past and raises questions about the potential for future water resources. Life: a central question. Earth, with its abundant liquid water, favorable temperature, and protective atmosphere, thrives with life in a vast array of forms. Mars, on the other hand, presents a much harsher environment. However, the search for extraterrestrial life is ongoing, with scientists investigating potential niches for microbial life in Mars' past or present subsurface environments. Both Earth and Mars offer captivating areas for scientific exploration. Understanding the differences between these two planets helps us appreciate the unique conditions that have fostered life on Earth and guides our search for life elsewhere in the universe. Mars, potential alternative planet for human habitation. Mars certainly holds potential as an alternative planet for human habitation, but it comes with significant challenges. Here's a breakdown of the pros and cons. Pros. Potential for water. Evidence suggests Mars once had flowing water and may still harbor subsurface ice. Water is essential for human survival and can be used for drinking, sanitation, and even fuel production. Similarities to Earth. Mars shares some geological similarities with Earth, including volcanoes, canyons, and polar ice caps. This familiarity could be advantageous in establishing settlements. Resources. Mars is believed to have resources like iron, aluminum, and potential for certain minerals. These resources could be crucial for building and sustaining a human presence. Reduced gravity. The gravity on Mars is about 38% of Earth's gravity. This could have some potential benefits for human health in the long term, although the exact effects are still being studied. Cons. Harsh environment. The Martian environment is currently very harsh for humans. The thin atmosphere offers minimal protection from radiation, and the frigid temperatures make it difficult for liquid water to exist on the surface. Distance and travel time. Getting to Mars takes months, making travel and resupply a significant challenge. The psychological effects of long-term isolation on Mars are also a concern. Building self-sustaining infrastructure. Establishing a self-sustaining colony on Mars would require significant technological advancements. Everything from breathable air and food production to waste management would need to be addressed. Cost. The cost of establishing a human presence on Mars would be enormous. The investment in technology, infrastructure, and ongoing support would be substantial. Overall, Mars presents an exciting possibility for the future of humanity. It's a challenging but inspiring endeavor that could push the boundaries of human potential. However, significant technological advancements and international collaboration would be necessary to overcome the hurdles and make Mars a viable home for humans. It's important to note that Mars is not likely to be a replacement for Earth, but rather an additional foothold for humanity. Our efforts to preserve and restore Earth's environment must remain a priority. Sending humans to Mars is a captivating goal for space agencies and private companies alike. It's a monumental task fraught with challenges, but also brimming with potential rewards. Here's a deeper dive into the what, why, and how of putting boots on the red planet. Why go to Mars? Scientific exploration. Mars is a treasure trove for scientific discovery. Studying its geology, atmosphere, and potential for past or present life can revolutionize our understanding of planetary formation, climate change, and the possibility of life beyond Earth. Expansion of humanity. Establishing a human presence on Mars would represent a giant leap for our species. It would signify our ability to extend our reach beyond our home planet and ensure the long-term survival of humanity in case of a global catastrophe on Earth. Resource acquisition. Mars may hold valuable resources like water, ice, minerals, and potential for energy production. These resources could be crucial for sustaining a Martian colony and future space exploration endeavors. Challenges of sending humans to Mars. The great distance. The distance between Earth and Mars varies greatly depending on their orbital positions, ranging from 34 million miles to 250 million miles. This translates to a travel time of several months each way, posing challenges for spacecraft propulsion. Current rocket technology requires a long journey. Advancements in propulsion systems are needed to reduce travel time and improve mission efficiency. Supplies and life support. Astronauts need food, water, and a breathable atmosphere for the entire journey. Efficient recycling and life support systems are crucial. Psychological effects. The isolation and confinement of a long-duration space mission can take a toll on mental health. Crew selection, training, and mission planning need to address these concerns. The harsh Martian environment. Mars is a hostile world with a thin atmosphere offering minimal protection from harmful radiation and extreme temperatures. Radiation shielding. Spacesuits and habitats need to shield astronauts from harmful radiation exposure. Temperature regulation. Maintaining comfortable temperatures within habitats is essential for human survival. How might we get there? Space agencies. Agencies like NASA's Artemis program are laying the groundwork with missions to the Moon, testing technologies, and gaining experience for a future Mars venture. International collaboration will likely play a significant role. Private companies. Private companies like SpaceX are developing reusable rockets and spacecraft with the potential to transport humans to Mars. These advancements could potentially lower the cost and increase the feasibility of future missions. Mission scenarios. Initial missions. The first human missions to Mars might be short-stay expeditions, focusing on scientific research and establishing a basic research outpost. Long-term vision. A long-term goal is to establish a self-sustaining human colony on Mars, where people can live and work relatively independently, potentially utilizing Martian resources for survival and further exploration. The road ahead. Sending humans to Mars is a complex endeavor requiring significant technological advancements, international cooperation, and a sustained commitment. However, the potential rewards in terms of scientific discovery, resource acquisition, and the expansion of humanity make it a worthy challenge. With ongoing efforts and continued innovation, this dream may well become a reality in the coming decades. Advantages and disadvantages of Mars. Mars, the red planet's duality. Mars, our dusty red neighbor, holds immense potential for the future of humanity. However, this intriguing world also presents significant challenges. Here's a breakdown of the advantages and disadvantages of Mars. Advantages. Potential for water. Evidence suggests Mars once had flowing water and may still hold subsurface ice deposits. Water is vital for human life and can be used for drinking, sanitation, and even fuel production. Resources. Mars is believed to have a wealth of resources like iron, aluminum, and potential for certain minerals. These resources could be crucial for building and sustaining a human presence. Scientific exploration. Mars is a scientific gold mine. Studying its geology, past climate, and potential for life can revolutionize our understanding of planetary formation, the possibility of extraterrestrial life, and our place in the universe. Reduced gravity. The gravity on Mars is about 38% of Earth's gravity. While the long-term health effects need further study, this could potentially have some benefits for human health. Disadvantages. Harsh environment. The Martian environment is currently very harsh for humans. The thin atmosphere offers minimal protection from radiation, and the frigid temperatures make it difficult for liquid water to exist on the surface. Distance and travel time. Getting to Mars takes months, making travel and resupply a significant logistical hurdle. The psychological effects of long-term isolation on Mars are also a concern. Building self-sufficiency. Establishing a self-sustaining colony on Mars would require immense technological advancements in areas like life support systems, food production, and waste management. Cost. The cost of sending humans to Mars and establishing a colony would be astronomical. The investment in technology, infrastructure, and ongoing support would be substantial. Overall, Mars presents an exciting challenge and a potential future home for humanity. The advantages of scientific discovery, resource acquisition, and the expansion of our species are significant. However, the harsh environment, immense logistical challenges, and the high costs require careful consideration and technological leaps before such a venture becomes a reality. The decision to send humans to Mars is not simply about the destination, but also about the journey itself. The process of overcoming the challenges of Mars will push the boundaries of human innovation and may lead to advancements that benefit life on Earth as well.